section here, we are going to begin by making the graph on Desmos. We are then going to draw what we see, and we're going to label the x-intercepts on each graph. Now, some of these equations may look familiar as far as what the graph looks like. Some of them we may not be as familiar with. So we're going to take a look at the first one together. So we'll go ahead and type in here y equals x. This is not a huge surprise that it's a perfectly straight line. We know that this type of function is linear. And so what we're going to do over here on paper is draw in a straight line passing through the center. And we're also going to go ahead and label here the x-intercept value of 0, 0. All right, now let's take a look at the next one here. So that y equals x squared, that's another one that should be familiar to us. But just for the sake of going through the full exercise here, when we put it in Desmos, sure enough, that is that familiar looking parabola shape. We're going to go ahead and draw that in here. And we'll label the x-intercept again as being 0, 0. I have a pencil sharpener right on the whiteboard. All right, let's also take a look at the next one together here, x to the third. Now, this is one that you may not have been familiar with, but we talked about it briefly at the beginning of the week. And that is a shape that looks like this. So it comes up from the bottom, and it looks like it gets very flat toward the x-intercept part, and then it just continues on upward after that. Go ahead and draw in a sketch here of x to the third. We'll label the x-intercept there as 0, 0. All right, so I'm going to give you a few minutes here on your own to finish the rest of this page. So I want you to go ahead and continue with the next 3 graphs. And then the second half of the page is asking you some questions based on the 6 graphs you made up at the top. All right, so I have up here what those next 3 graphs should have looked like. So we actually have a few similarities between some of the graphs that we see up here, kind of some similar shapes. In the second half of this page, it's wanting us to use some words and phrases to describe what we see happening at each x-intercept. So we have these 3 choices. We can describe it as, well, it looks like the graph bounces on the x-intercept, or it wiggles through the x-intercept, or it just simply crosses through the x-intercept. So let's start with that first option of bounces on. Would somebody be willing to share out what graph or graphs you labeled as a bounce? Start us off, Maya.
All the ones with an even.
Even exponent. Okay, I like that. So it seems to happen 3 times here. So I'm going to actually go through and label each of these pictures, x squared, x to the 4th, and x to the 6th. And so if we think about the x-axis as being like the floor, and we see that the path of the graph is like if you were to drop a ball, and it touches the floor, and then it bounces right up, or it touches, and then it turns around, it goes the opposite direction. Anytime that happens, we're going to label it as a bounce. And I like what you noticed about the exponent. So I'm going to label that off to the side here as well, that we have an even exponent for each situation that resulted in a bounce. All right, the next option we had, the phrase, was we said, well, we could describe it as wiggling through. So which of the graphs did you label as a wiggle? Go ahead, Jack.
The ones with an odd exponent, that's not 1.
An odd exponent that's not 1, yeah. So we see it for x to the 3rd, and we saw it again on x to the 6th. So it looks like it's coming up, and the wiggle part is where it gets a little bit flat on top of the x-intercept. It kind of looks like it bends a little bit, and then it keeps going. And I like how you clarified, it's not just an odd exponent, it's an odd exponent that is greater than 1. All right, so we just have one description left, and we only have one graph left, and so this was the one that we should have labeled as crosses through. Now, technically the wiggles also cross through, but they have that little bend, and so we call it a wiggle. Well, if it just crosses through and it's more of a straight line, if it looks very straight through the x-intercept part, we're just going to call it a cross. Now, technically, what is the exponent that we see here? Go ahead, Jacob.
1.
Should be 1. I'm going to make a note here, exponent equals 1. All right, we're going to go ahead and turn our page over to the next side. We're going to continue this idea of exploring graphs. We're going to be thinking about everything we've talked about so far with the bounce and the wiggle and the cross, and what connection that has to the exponent that we see. All right, now we're going to be doing a little bit more work here with Desmos to help us explore a few more complex equations. So we're going to take a look at this first one together. I'm going to actually type this into Desmos just exactly the way that it's written there on our paper. So in parentheses, we have an x minus 1, and that is being squared. And right next to that in parentheses, we've got x plus 1, and that part is also being squared. So let's take a look here at what our polynomial graph looks like. We can see here that we have 2 x-intercepts now. And actually, the nice thing about Desmos is that if you click on the x-intercept point, it's going to just tell us what they are. So we've got an x-intercept at -1 and also at +1. All right, now I want you to look at this with me carefully. We're going to start on the left-hand side at the x-intercept of -1. And I want you to decide, how do we describe what is happening? So as the line comes down, it's going to touch this x-intercept, and then it's going to turn around. I want you to tell your shoulder partner, is this a bounce, a wiggle, or a cross?
That's a bounce. That's a triple bounce.
Okay, let's talk about this one over here, because we're just specifically looking at what happens at the x-intercept. What's happening on this one?
Bounce.
Another bounce. Okay, so anytime it touches and it turns around, we will label it as a bounce. Okay, so let's get this all here on paper. So we're just going to sketch our x-intercept here. We're at -1 and +1. It was a bounce for each, which just means it's going to touch that point and then turn around. Now, for the middle section here, when you go to label your x-intercepts, I want you to actually label them vertically, like one right on top of the other. You'll notice here at the very top of this table, x-intercepts are also known as zeros. So that's a little something that's going to be important throughout Chapter 5. If something is referencing zeros, we're really talking about the x-intercepts. And I wanted you to stack them in this way so that we can draw an arrow off to the side here and write the appropriate letter to represent what's going on there. So because it was a bounce on each one, I'm going to label a B next to each one. Okay, hey, let's look at the exponents. So remember what we talked about on the first side. What type of exponent should it have if it's a bounce? Even. So that could be like what?
4 to 6.
Okay, so if we look over here at the exponents, they're even. We have an exponent of 2 and another exponent of 2. So that's something I want you to notice. So that is in line with us seeing that there's a bounce there. Okay, let's take a look at the next equation. So the only difference here is that the exponents have turned into 3. Well, what would you expect if the exponents? Okay, we're going to go over here to Desmos and check. I am just going to change the 2's to 3's. See if we'll actually get it up to an exponent. And we're going to see what this looks like here on the graph. Okay, so we've got a different looking graph, but we do still have the same x-intercept. And so sure enough, let's look at this first one here at the -1. Notice how the line comes down a little before the x-intercept. Notice how it gets a little bit flat on top of it, and then it continues on downward. So yes, that is a wiggle. The wiggle goes all the way through, and it has a little bend. Now let's look at this side. This is what the wiggle could look like going the opposite direction. If it's coming up from the bottom, it comes up a little before, it gets flat on top of it, and then it keeps going afterwards. So we're going to do the same thing over here on our paper. We're going to sketch a picture of what we saw. Same x-intercepts of -1 and +1. Okay, so here's my advice when you draw the wiggle. Kind of like what I was describing on the decimal graph. So on this first part, when you come down a little before the x-intercept. Make it flat on top of the x-intercept. And then make it go down after. It's not probably going to look as nice or as perfect as it does on decimals. That's totally okay. Mine are not perfect. We're just doing a basic sketch. All right, now we need to have this turn around so that we can come up, make it flat, show that wiggle on the other part. It takes a little time to get the hang of all the pieces. Okay, so we have the same x-intercept as we did before, but we're noticing that these are both wiggles. So let's just make a little note here. So this makes sense that they're wiggles because the exponents were both 3. And let's actually go up here to this one and make a little note that, well, this one made sense, that they were both bounced because the exponents were even. They were both 2. Well, Arno, we are going to find out. So in the next graph, now we see that although the parenthesis parts have not changed, the exponents have changed. Actually, so one of them turns back into a 2. What is really the exponent of this one? It's really a 1. So actually, let's get into the habit of drawing in the 1. If you don't see it, it's really a 1 that's there. All right, I want to go to decimals here and show you what's happening. So I'm going to change my first exponent there to a 1, or you can just get rid of the exponent altogether. I'm going to change the second one over here to a 2. And it looks like we have the same x-intercepts, but I want you to turn to your partner and tell them how do you describe what is happening at the first x-intercept, what is happening at the second one. All right, guys, we're going to come back together. Sometimes it can be a little difficult to identify what's happening at first. So let's break it down. So let's take a close look at the -1. It is coming up to the -1. It's touching, and then it turns around. So what do we call it anytime it touches and turns around?
Bounce.
A bounce. And if it's coming up from the bottom, that's like taking a ball and throwing it on the ceiling. It's going to touch, and then it's going to turn around. Okay, so this one is a bounce. Now we're going to ignore this over here. You guys, this is just called a turning point. That's all it is down here. It just means it's changing direction. But we're not labeling this, we're not naming it, because this is not at an x-intercept. We're only labeling what happens on top of the x-axis. So let's go over here to the other x-intercept. And we're just going to look at, like, maybe starting here, where my finger is pointing, as the line kind of goes through like this. What would you call it?
Cross.
It's just crossing through. Yeah, so notice how there's no bend, there's no wiggle, it's not getting flat, it's very, very straight at that little piece, so it's crossing through. Okay, let's get this over here onto our paper. Okay, so I'm going to plot the x-intercept again. So we've got a bounce here for the first one. We just have a turning point, and then it's a nice kind of straight cross through on the second one. So at -1, it was a bounce. And then at +1 here, it is a cross through. Yes, Joey?
If -1 had the exponent of 1 and
positive 1 and the exponent of 2, why would it be switched on the graph? Why would the bounce be on the negative 1?
That is a wonderful question that we are going to answer right now. Isn't that an interesting observation that the symbols seem to be opposite of what we would expect it to be? Let's take a close look at the bounce. Now, we know that a bounce should have an exponent of 2. Well, if we look at the parts that have an exponent of 2, it's actually the x plus 1. Well, there's not a mistake here. It is actually true that the x plus 1 part in parentheses is going to correspond with an x-intercept of negative 1. And so, actually, let's make a little note here that, yes, this is the opposite sign of the number in the parentheses with the x. And it has to be, right? Because we see that that's the part that has the bounce. We know that bounce has to be an exponent of 2. Let's look at the other one. So if we look at the cross, now we know that a cross is going to be an exponent of 1. Well, the part that has the exponent of 1 is listed first. That was actually x minus 1. Sure enough, that seems to follow the same pattern that the minus 1 in the parentheses. It turned into the opposite sign when we wrote it out as an x-intercept. So we've made the observation that it's happening. Let's talk about why. It has to do with the process algebraically for finding an x-intercept. When we want to find an x-intercept, if we're going to solve for one, the y value is equal to 0. So what we can do here with the equation is actually plug in 0 for y and solve for x. Now, if you plug in 0 for y, right at the very beginning, so instead of writing it as y equals, we're going to write this as 0 equals. Now, we've seen equations like this before in the past. We did this back in first semester. We had quantities in parentheses that were being multiplied together, and the result was equal to 0. Well, the way that we solved those is we set each quantity equal to 0 and solved each one separately. So let's try that for the x minus 1 part. Well, in order to get x by itself, we have to add 1 to both sides, and that's why it changes to the opposite sign. So the value of positive 1 is the actual x-intercept value, but it came from the parentheses x minus 1. So that's why we're switching signs. Now, if we were to check it over here on this one, we're going to see the same thing happen. When we set that one equal to 0 and solve for x, sure enough, it's going to change to the opposite sign, and that's giving us the other x-intercept. All right. I want you to try one more of these. You're going to do this one on your own. So down below, I want you to actually just try number 5. So you're going to start this off in the same way. You're going to go ahead and graph it in Desmos, draw what you see, and then I want you to list out the x-intercepts, what's happening at each one, and then I want you to make some observations about how that compares to the original equation. All right, so let's put it together. We're going to take a look here at the graph of number 5. So I graphed it on Desmos. I just drew what I saw. And as I start to list out the x-intercepts, I'm just going to start on the far left of my graph, and I see that I have that x-intercept at -2. How did you label this one? What did you all notice is happening here? Looks like it is a wiggle. Now let's make a quick connection here to our equation. So it looks like the one that has an exponent of 3, an exponent of 3 should be the wiggle. And sure enough, notice how it's the opposite sign in the equation. It is x plus 2, which makes sense because our x-intercept was -2. I want to show you that that is still happening. let's get our next x-intercept. This one next had an x-intercept of 0, 0. How did you label this? What is happening at 0, 0? It is a bounce. Yes, it touches and then it turns around. Now we know that a bounce should have an exponent of 2. Actually, the other two factors that remain both have exponents that are 2. But the one that corresponds to the 0, 0 is actually the x squared at the very front. It didn't have a parenthesis, and so it doesn't have a number that you can change to the opposite side. Actually, a way that you can think about this, what I like to write out sometimes, is instead of it being x squared, you could put in parentheses, and you could write it as x minus 0 squared. Different way to say the same thing, but there you have the 0 that is going to connect to this answer here. It's just 0. 0 is not positive or negative. It just stays 0. So that was something I wanted you to see on this one, that if you have a single x in the very front, or in this case an x squared, even down here is an x to the third, it's going to be a 0, 0. Okay, the last x-intercept we have here is 1. And how did you all label this one? What is happening right here? Yes, it is another bounce. And again, we know that bounce should be an exponent of 2, and sure enough, if we take a look at the last factor, it has an exponent of 2, and the positive 1 is the opposite sign of the negative 1 that we have there in the parentheses. All right, we are going to turn over to page 7, and at this point, if you have decimals up displayed, I'm going to have you go ahead and close your computer screen. If you were utilizing that on your phone, I'm going to have you go ahead and put your phone away. The goal to finish this up now on page 7 is to do all of this without using any sort of technology. All right, now we're going to start off our summary page with a vocabulary term that is going to describe the exponent attached to each factor. Well, instead of just calling it the exponent, there's actually a more formal name here. It's called the multiplicity. So if the question is asking you for multiplicity, it really is asking, hey, what's the exponent that's attached to the factor? So if the multiplicity is 1, it's going to cross through the x-intercept. If the multiplicity is even, it's going to bounce on it. And finally, if the multiplicity is odd and greater than 1, it's going to wiggle through that x-intercept. Each individual factor has its own multiplicity. It's not like the degree, where it's just one thing. Each little part raised up to an exponent is what we're going to be considering. So we're going to go through all of the steps here. We're going to put all the pieces together for this first equation. We've got the quantity x minus 2. That is really raised up to the first power. So let's put a little invisible 1 up there. And that's being multiplied by x plus 3. That's raised up to the second power. All right, so we're actually going to begin with the end behavior. So that was kind of our big topic earlier on in the week. We can notice here for end behavior that this one is in factored form. And so in order for us to get the degree, we need to add the exponents that we see. So we're going to be adding the 1 and the 2. We see that the degree is 3, which really for us that's important because we can recognize that it's odd. Now the leading coefficient, the invisible number out at the very front, it's just 1. What we can take from that is that it is positive. So that's going to put us into the category for end behavior, it's going to be dominant. All right, now right here, when it is asking us for the 0, that is another name for the x-intercept. All right, and we're going to look at this just one piece at a time. So I'm going to highlight the first little piece here. We're going to look at that x minus 2, and we're going to change it into positive 2. It's really like we set that part equal to 0 and solve for x. Kind of a shortcut way to think about it is, hey, it's just going to be the opposite sign. Now the multiplicity is just the exponent that's attached to that part. Notice how the exponent on that part is 1. And because it's a 1, it's going to cross through that x-intercept. All right, next little piece here, I'm going to highlight that in pink. What should we say for the x-intercept? -3. It looks like +3. We're going to change it to the opposite sign. What is the multiplicity of that one? 2. And because it's a 2, it is going to bounce. Perfect. One other piece that we are going to think about with our graphs, we haven't talked about it yet today, but we've done a lot of work with this throughout the year, and that is finding the y-intercept. It's actually very easy to do. It's the same process for finding y-intercept that we've done in the past. All we need to do is plug in 0 for x and solve for y. So that looks like this. Replace every x in the original equation with 0. And then we're going to think carefully about order of operations. We're going to think about PEMDAS to simplify it down. So we're first going to simplify the little parts inside of the parentheses. So 0 minus 2 is -2. 0 plus 3 is 3. The next thing we would do here is evaluate the exponent. So we are just going to do 3 squared, which is 9. And then finally, we can multiply them. In the last step, we get our y-intercept is -18. All right, now we get to put it all together on our graph. So we are going to begin by drawing in an x-axis and a y-axis. What I start to label first are the x-intercepts. And I'm going to show you how I like to do this. So for the first x-intercept of +2, I'm just going to make 2 little tick marks here. We're going to assume together that each tick mark represents 1 space. And so I'm going to plot a point here at that x-intercept, but then I'm going to label it with a C. Because I want to remind myself when I'm drawing the graph that it's going to cross through that one. Now over here, let's do the x-intercept of -3. And I'm going to put a little b next to that because I want to remember that it's going to bounce. Now, you don't need to be as detailed when you label your y-intercept. On this one, to get down to the -18, you don't need to draw 18 little tick mark spaces. Instead, all I want us to do is go ahead and plot a point down here where the y value is a negative y-intercept value, and I just want you to label it as -18. Okay, finally, the end behavior, that's how we're going to start to draw through our graph. Because we need to know where this starts. Does it start coming up from the bottom, or does it start coming down from the top? So here's how I like to put the end behavior in. On the far left side, I'm going to do my down arrow. On the far right side, I'm going to do my up arrow, because I know that it's supposed to be down up. All right, now we're going to start drawing this through. So I'm going to start with this little down arrow on the left side. I know it has to bounce on the first x-intercept. So I'm going to make sure that it touches that x-intercept, but then it's going to turn around. It's not going to actually cross all the way over. All right, now to get it to the other x-intercept, to get it all the way over here, we have to have a turning point. This thing has to change directions, and when it does that change of direction, it needs to go through the y-intercept. That's really the only purpose of that -18 to be there, to give us a little point that we know we've got to cross through. It's going to look something like this. Now, as we're getting closer to the last x-intercept to cross through, we just want to make sure that this little section right here is very straight. We're not going to have any sort of wiggle or bend, and so it's going to end up looking something like this. There is a similar problem right below this one that I want you to try on your own. So you're going to go through all the steps from start to finish. I'll give you a few minutes to try it out. All right, so coming back together on this one, this is how we should have started to fill the chart in. So starting with n behavior again, we end up seeing that it's an odd degree positive leading coefficient. So this is also down up. And this one actually has 4 zeros. It has 4 x-intercepts. And when I'm listing them out, you don't have to go in order from the equation, but I tend to just list them in order going from left to right. Notice that we have this x out in the very front. That's going to correspond to an x-intercept of 0, 0. It's kind of like x minus 0 in parentheses. That one is raised up to the first power, so the multiplicity is 1, so it's going to cross. Now, for the rest of them that did have numbers in the parentheses, I just took the opposite sign of the number in the parentheses. I looked at the exponent for each part to get the multiplicity, and that's what told me if it's a bounce, a wiggle, or a cross. Really, what's going to be most common is just the exponents of 1, 2, and 3. So honestly, to kind of learn this, if you just know that 1 is cross, 2 is bounce, 3 is wiggle, you're going to do great. Okay, here's a fun fact about the y-intercept. If you ever have an x-intercept of 0, 0, your y-intercept is also 0, 0. If you look at this on the graph, 0, 0, it is both an x-intercept and a y-intercept at the same time. Now, algebraically, if you plug in 0 for x and try to start solving it for y, at first, it may look like it's going to be a big, long calculation, but the 0 out in the very front, 0 times anything is 0. So that kind of saves us. It just makes the whole thing 0. All right, and then for the graph part here, I still need to finish it, but I just wanted to show you. So this is how I start to write it out. So I'm going to label the x-intercept, and I'm going to label if it's a bounce, wiggle, or cross. And here's how I'm going to finish this up. So I'm going to go ahead and put in my end behavior. End behavior arrows, that is how we get started to actually draw the curve. So on this one, we are going to be coming up from the bottom. The bounce means that we're going to touch and turn around. Now we need to have a turning point. I don't care how far down your turning point goes. We are just doing a basic sketch here. I just want to see that it turns around so that you're ready to wiggle through the next piece. Now for the wiggle, I'm going to come up a little bit in front of it so that I can make it flat, and then I'm going to go up after that. Now on this one, we actually need to have like a really sharp turnaround, again, because now it has to cross through the next point here. So it's going to turn around. And it's not super pretty. I'm sure Desmond looks much nicer, but it's a nice straight line for the part where it's supposed to cross through. It's going to be a little bit easier to finish it up here on the end because we just need to have one more like turning point so that it can go ahead and cross through the last piece. All right. So what we're going to look at now at the very bottom of your page is seeing if we can take what we've learned and go the opposite direction. So to finish up today, we are going to see that we have a graph that is already drawn. And we are going to write our equation in factored form down below the graph. Now the first one here has a little part of it that's cut off. If we were to continue, so it's supposed to be getting flat at this point, and then it's just supposed to go upward from there. So just kind of draw that little piece in. I just want to model for you here aloud how I would think about getting an equation for this first graph. So here's what I like to do. So the first thing that I'm going to look at is the x-intercept. And I'm going to label the number, value of the x-intercept, and I'm also going to label what's happening. So on this first one here, I can see that it is at -4, and it's crossing through -4. So here's how it's going to look like in the equation. If the x-intercept is -4, we need to change it to x plus 4. And if it's crossing through, you can make the exponent an invisible 1, or you can write a little 1 in there, just as I've done. All right, next thing I'm noticing is that it is a bounce x -1. So what should I put in the parentheses for this one? Go ahead, William. X plus 1. And because it's a bounce, what kind of exponent should it be? A 2. All right, the last piece over here, this is supposed to be a wiggle through positive 3. If this x-intercept is positive 3, what should we put in the parentheses?
-3.
And what kind of exponent does it have?
3.
Awesome. All right, we have a couple minutes left here. Feel free to try the next one if you want on your own. You're going to get a chance to practice in your assignment for tonight, which is this green paper that I am going to pass out to you now.